Hello and welcome to this repair tutorial, and today we're going to look at an Alesis RA150 amplifier. These amplifiers are also used extensively in studio use because it has a 2U 19-inch rack design. One of the important factors is that it doesn't have any internal cooling fans. So the amplifier, to all intents and purposes, apart from a small amount of hum which comes from the conventional EI transformer inside of it, is silent. So often it's used for that. You do get a larger version of these amplifiers as well. So there's an RA300 and there's also an RA500, which is of course the bigger version. So sort of overview of specifications. What I would say is that this amplifier sometimes also comes under the Behringer badge as well. And I've seen a number of them. It's the same amp, but just has a different name on the front. And in terms of general specifications, for power output, RMS is 75 watts per channel, and that's if you're driving into a 4 ohm speaker load. And then that comes down to 45 watts RMS times 2 into an 8 ohm speaker load. And as is common with these types of amplifiers, at the rear, which is just underneath the power, or just to the left of the input selection then for the right channel, you'll see that there's a small slide switch, and that's where you can select the stereo, or you can select what we call bridge mode. If you're running into bridge mode, then your power output RMS then 2 times 8 ohm speaker connection, but of course it's just coming through the one, it's looking at 150 watts single output there. So that's good, right? So hence where you're getting the 150 from with regard to the model number. And then signal to noise ratio is greater than 105 dB. Frequency response is good, so you're covering a range of 10 Hertz to 70 kilohertz. And then total harmonic distortion, 4 ohm speaker load, is 0.02%, and that's from 20 Hertz to 20 kilohertz. What the amplifier has in terms of design, it has a DC or a servo offset circuit. So what you have in there is you have feedback, which will continuously monitor via comparators. And what it's doing there is it's just looking to make sure that you have the maximum permissible DC offset. So it's never going to exceed plus or minus 50 millivolts. And then your input jacks are 1/4 inch jack, and then you also have unbalanced RCA phono inputs, and I'll drop a link in the video because I also covered on a previous tutorial what the difference was between balanced and unbalanced type inputs. So again, if you have additional times, by all means review that repair video. And then the speaker terminal connections on the rear, you have terminal posts. And then what you can also connect are 4mm banana jacks if you wish. I'd sort of draw this to your attention as well. Just on the rear of the amplifier, you can actually select the mains voltage power input. So here you could select, for example, between 120 volts or 230 volts. The only caution is, and I'll sort of do like a bit of a retrofit on here, often I see these amplifiers, there's 2 fixing screws either side, which hold the switch in place. But there's no cover plate, which seems a little bit strange. I'm not saying it's easy to accidentally, slide the switch to the wrong position, but it could happen. So what I do there is I just put a small plastic cover, transparent plastic cover over there, just to prevent that from happening. And then dimensions-wise, you're looking at a height of 99, width of 480, and a depth of 260 millimeters. And then overall weight is 6.8 kilograms. Now, what I would also say is that this amplifier is extremely well built. When you look at the construction of it, really, there's no sort of compromise. So it's designed extremely, it's extremely sturdy design, very thick metal that is used. And then if you need to get access from the for the top, you've got 6 fixing screws on the top. But if you're sort of thinking, well, where's the other ones? Because I still can't get the lid off. Just look to the left and the right hand heat sinks, and just towards the top from the side, you'll see that there's additional 2 screws either side, and then once they are removed, you'll be able to get access then to the top. Just be aware that the rear top plate screws also have small little washers on, whereas the front ones, the sort of the indented part of the top plate forms the washer, so there's no additional washers that you require. So what was the issue with this amplifier when it came in? Well, there was a couple of issues, but one of the issues is probably the most common one. So what I'm showing here in the video is of course with the top cover removed, what you'll first notice is that there was a huge amount of dust inside the amplifier. So first thing to do here, of course, is to try and clear all of that out. So that's a compressed air line and stiff brush in most cases, but you know, it wasn't as if any liquid had gone in there, so it wasn't binding to the boards, and it was very, very easy to remove. And then once that was done, it got an initial power up because there was a visual inspection just to check the rear fuse to make sure that it wasn't blackened, i.e. excess current drawn, which it was not. And then I just powered it up via the dim bulb tester, and there wasn't sort of any indication of excess sort of current or anything like that. But there was a number of things which kind of noticed straight away. What you should see is the front LED just on the top fascia should illuminate blue, and it wasn't, it was off, so kind of indicating as if, you know, there was an issue there with the power supply. And after about 5-6 seconds, you should hear the speaker protection relay, which is located on the power supply board, change over. And this is a 12 volt double pole relay, and there was no click at all. So it's like, oh, okay, so is there an issue with the power coming from the transformer? Because I don't have any LED indication, you know, what's going on. So the first initial checks before I sort of got underway with the fault finding is just to verify from the power transformer. And I'm sort of showing this in the video. You have the connector which comes from the power transformer and then plugs onto the board. Now there is a fault which does occur, and you can see here that you have the the actual connector as a yellow, black, and then yellow lead for the center tap, and then just in front of it there's a 100 nanofarad capacitor. Just be aware that sometimes you might get like the fuse blowing on the rear of the amplifier, and you think, oh, maybe one of the output channels has gone. But often what you'll find is this small high frequency filter capacitor just goes short circuit. So just check that, it wasn't an issue here. But once I disconnected the connector, I could just verify that I actually had the AC voltage coming from the transformer, and everything was fine. So that told me, okay, there's more an issue that's probably going on the power supply board, or maybe on the front indication board. So first things first, once I'd verified that the voltage was present, what I do is I just disconnect the left and right channel power modules. So you have the multi-pin connectors which come in, which bring this signal out to the rear speaker terminals via the protection relay, and then you also have the signal leads which will verify if there's any excess DC, which will be fed then to the protection circuit and then would operate. So once I've done all of that, the next thing that I do is I just power it back up again via the dim bulb. And what I'm listening again is, you know, why is there no click? Well, I know from experience, and I've repaired a huge number of these amplifiers, that the most common issue that you have is that the speaker protection relay just goes open circuit, or that the speaker coil that the switching coil goes very, very high resistance. And that was exactly what the issue was here. So it's quite straightforward to remove the board. You just have a small nut which secures via a bolt the bridge rectifier, and then you have a series of sort of cap screws on the top of the power supply stroke speaker protection board. And once you remove those and then unplug the cables, of course, from the power modules as I mentioned, what you will be able to do is lift up that circuit board then. So rather than sort of, you know, try and do sort of measurements, the first thing I'm going to, or I did do, was to desolder that speaker protection relay and then just drop a meter onto the coil, and sure enough it was reading open circuit. So it's quite straightforward, just a 12 volt relay as I said. Pop a new relay in there, and then what I'm also looking to do is to do some additional work as well. And what I show next in the video is an overview of the power supply. Now the power supply stroke speaker protection board, where the power plugs onto the main board, what you'll find is that there are drop-in resistors on there, and I'm sort of highlighting these on the in the video now. And these drop-in resistors are R401 and R402, and the value of them is 470 ohms, and they are 2 watts. Now, depending how much the amplifier has been used, you may find a little bit of discoloration on the resistors, or you may not even be able to read what the resistor color codes are. Here there was a slight amount, but what you could smell was that, you know, these components, and I'll use the word, they just go smelly, right? So this is the sort of the chemical construction of the resistor, and you know, if this thing's going to be used, well, not just in studios but used at all, the last thing that the customer wants is, you know, you sort of leave the room for a bit, maybe make yourself a drink, come back in, then you're thinking something burning, you know, it doesn't smell too good. So what I do is, just as a matter of course, I will replace those resistors, and what I do is I just uprate them rather than just being 2 watts, because they're kind of running pretty hard. I just increase that up to 3 watts and put brand new resistors in. And then what I also do, and I'll sort of show you this now in the video, is once the resistors are installed, I will sort of push them out to the left and the right. And the reason for that is these resistors act like radiators, and they generate a lot of heat. And what you'll find for the design is that there are a series of electrolytic capacitors which are mounted very, very close to these resistors. And then what happens is that these electrolytic capacitors dry out very, very quickly. What you'll find here is that you have the plus and minus 15 volt supply, and the capacitors, the required replacing here is C404 and C403, and then the value is 220 microfarads at 25 volts. And then what I'm showing here in the video is the ESR meter showing that they are open circuit or very, very high equivalent series resistance. Now at the same time, what I also look at, because these electrolytic capacitors are close by, you have the electrolytics which are then used for the 12 volt power supply. And remember that 12 volts power supply is also being used for the voltage to switch the speaker protection relay. So not good if you've got issues where the electrolytic capacitors after rectification are doing pretty much nothing at all. So just replace them. So here we replace C707, which is a 47 microfarad capacitor, and then we also replace C408, which is a 100 microfarad 16 volt capacitor. And once those two were replaced, that effectively really is building a lot more longevity back into the repair of the amplifier. And then the other thing which I'm sort of drawing your attention to is, once that board is sort of up and removed, if you turn the board over, of course, which you'll need to do to remove and fit the new components, what you'll find is that there are heat related issues, and that is very, very common. So again, inspect that board and just reflow as required any areas that you can see where there is discoloration, and I'll show this in the video. All right, so you need to sort of take care of that and just prevent any further issues. The other thing that I'll draw to your attention, which is again shown on this photograph here, just towards the back of the board, you can see that there's a small vertical circuit board, which is almost like a sort of surface mount. I have seen, and I'm aware of, 2 different types of designs of these circuit boards. So some of them will have discrete components within the protection circuit, and then some, like this amplifier, will have this small vertical kind of hybrid board. So I'm just bringing you to your attention. In terms of repair, it's still the same faults that I've described for either one of the boards. The boards have not fundamentally changed as such in terms of design. And as I said, you know, the ESR meter, you know, will quickly identify, you know, if you've got any issues then with the capacitors. So once that was done, the board was reinstalled, and then what I do is I don't connect the left and right channel modules at this point in time. The next thing that I wanted to do was just to verify that the speaker protection relay changed over, and then you know that that board is fully operational. So sure enough, power it up, and then after about 5 or 6 seconds, you hear the click of the speaker protection relay, so you know potentially, you know, you're kind of in a good position then to do further testing. But as we said earlier, the LED on the front fascia was not illuminating. So what's the concern there? Well, it is powered from a DC voltage supply. So again, what I show here, and I refer to it as the LED board, and that's as per the service schematic. What you can see, and what I've identified here, is that it's a case of just checking the DC voltage which is coming to the power LED. And sure enough, the voltage was reaching to the LED, but it was still high. So that indicated that there was no volt drop. So potentially the LED was open circuit. So once the board was removed, it's a straightforward task. And again, I show you in the video what that circuit board looks like. A straightforward task of just simply desoldering the blue LED. And this is equivalent of a 3 volt, 3mm blue LED. And you can just drop it onto the multimeter, and sure enough it was open circuit. You can also verify, of course, just if you've just got a small DC power supply, you know, if it's 3 volts, you can drop it on there. But sometimes with some multimeters on diode check, you may also have sufficient drive voltage from the multimeter just to illuminate the LED. So that's also a sort of a common thing which service engineers or service technicians will do. So easy fix, what I did here was just to replace the LED, and then rather than just install the board straight away, just power up the amplifier. Power indication was nice, good, nice and blue, and then just reinstall the board after that. And then the other area to sort of take care of are the user control potentiometers. So this is where you will adjust the right and left channel volume. And as with all audio power amplifiers, what you can find is that they get dust or contamination just onto the carbon tracks of the potentiometers, resulting in excess noise when you adjust it, or sometimes intermittent loss of sound. Now, with this series of amplifier, what you can find is that the volume control potentiometers can become loose. And what I'm going to draw you to attention to is two things. First of all, don't do this, right? So the don't do this thing is don't take a flat blade screwdriver and go from the front and then try and prise off the volume control knobs. If you do that, you're probably going to damage the fascia, and you most likely will damage the edge of the volume control knobs. So don't. All right. But what you should do is, if you look from the back, what you'll find is there's small access holes. So it's very, very easy then just to take a blunt tubular piece of metal, you know, or a blunted screwdriver, positive drive, something like that, just with the end sort of off, so you're not going to poke through. And then what you're able to do then is just push from the rear, and then if you just wiggle it slightly from the front, the volume control knob, it comes away very, very easily. And then what you'll see there is the locking nut which holds the user control potentiometer in place. Straightforward. You know, don't use a pair of pliers because you could slip. You know, just take an adjustable spanner and then you can just lock them into position, and it's dead easy after that. Just put the knob back onto the volume control potentiometer. So these potentiometers, you know, we just clean with high quality switch cleaner, which is De-Oxit, and then that just confirms, you know, during the test phase that everything was all good. Now, when we come to the test phase of the amplifier, remember that we'd already disconnected the left and the right channel, which is correct, to fix the power supply and speaker protection board. So what I do here is I don't just plug the two modules on, because remember, I didn't really have a lot of information about this amplifier before it came in. So I'm just going to take a degree of caution. So the first thing that I do is I just connect the left channel module, leaving the right one disconnected when looking from the front. And then I then power up the amplifier. And then what you'll find is with the dim bulb test, it has a 100-watt filament bulb in there. It will light, you know, a little bit, but not too much. But it's enough current is flowing then, and then you'll hear the speaker protection relay change over. And what I can do is I can quickly put my meter onto the rear speaker terminals, verify there's no high DC offset. Well, there isn't, but if there was, the protection circuit would have tripped. And then I then can feed in some audio. And that channel was working very, very well, no concerns. And then what I do then is I just depower the amplifier and I repeat the same test, but now removing the left channel connections and then reconnecting the right and then doing the test again. Amplifier powered up fine, relay changed over, and I could run audio through with no issue. So I'm very confident at that point that there's no sort of underlying issue either with the left or the right channel modules. So connect both, and then I can then switch over then onto full power mains and then run the amplifier up. And as you probably figured, you know, there wasn't any other underlying issue with the amplifier at all, and the sound quality was, you know, really good. Of course, there was also a test just to verify that the bridge mode worked, but you know, that's sort of done as normal test, and then the normal things for total harmonic distortion and quality then of audio. Just for people for reference, you may already be aware of this because I've mentioned this on previous repair tutorials. You know, if you're going to run a test signal into an amplifier, you know, it's very common. We tend to say that it's a 1 kilohertz sine wave. And then if you look at the technical specifications for the amplifier, it will tell you what would be the input maximum millivoltage. So, you know, 100 millivolts nominal is fine, just to verify that everything is working correctly then. All right, so only thing that sort of remained as per all of the other audio repair tutorials is just to give the amplifier a deep clean. All the dust had already been removed, as we said earlier, with a compressed airline, and then just, you know, clean the amplifier up, make sure that everything is fine, and then just do a functional test. So that really brings us to the end of this repair tutorial. So I really appreciate you stopping by. And again, if you have any questions or you need any sort of further information, by all means email audio amplifier servicing at aol.com, and I'll be happy to come back and provide any guidance or assistance you may require. All right, so until the next time, cheers, bye bye.